Hello, good morning. A few housekeeping items first. If you have a cell phone or other device that makes noise, if you would like to make sure that is in silent mode, that would be fabulous. Please hold your questions during this talk until after the talk. Katie will be taking questions at the PyLadies booth, so you can find her there. So please welcome Katie, who will be giving the talk titled A Right Stitch Up, Creating Embroidery Patterns with Pillow. Thank you.
Good morning. A long time ago in a conference far, far away, I gave my first ever lightning talk. It was in a series of lightning talks that were specifically about other skills. It was any lightning talk you wanted, but it couldn't be about computers. There were talks about bread making, there was talks about a choir, and I gave a talk about a cross-stitch that I made. The original artwork was created by a pixel artist from Melbourne, Paul Robinson. He's known for his work on Scott Pilgrim vs. the World, the video game, Mercenary Kings, and the video clip for Architecture in Helsinki's Do the Whirlwind. Pixel art, especially those with really distinct colour palettes, map really well into cross-stitching. Every single pixel on that image can be converted into a single stitch. And you can import your designs into one of the many closed-source Windows-only programs and generate a chart for your reference. Each cell has a colour and a symbol that you then transcribe by hand onto your canvas. This particular one took 3 months to make. But several years after my original lightning talk, this particular design was auctioned off as part of the PyLadies charity auction in Portland in 2017. And the money raised went directly to PyLadies. Now, as part of the lightning talk that I gave those many years ago, I mentioned that the program that I used was a closed-source, Windows-only program. And I said, if you know of anything about image manipulation, color setting, cross-stitch charts, if there is any free and open-source software out there, please tell me. Otherwise, I will make my own and present it here next year. Unfortunately, that was in 2014. I am not very good at estimating. But based on my own unscripted ramblings from now 5 years ago, I set myself 3 problems to solve. 1, image manipulation. 2, color setting. And 3, cross-stitch charts. First step, image manipulation. If I'm provided an image, I want to be able to go through and iterate over every single pixel of the image and work out what color it is. In Python, we can do that with Pillow, the Python imaging library. Pillow is the go-to language if you want to do image manipulation. It's a go-to package for image manipulation in Python. You can use it to load images, resize them, rotate them, and then save the result. But you can also interrogate images using image.getPixel, and it does pretty much what it says on the tin. If I have a 3x3 pixel image zoomed in here, because otherwise it would be really small on the screen, I can identify exactly what color each of those pixels are. The coordinate system in Pillow starts at the top left, and it works its way across and then down. So, in my terminal, if I pip install Pillow, open up my Python terminal, from Pill, import image, open up my image from my local file system, and then run getPixel with the coordinates 0, 2, I get out a triple, so a 3-element tuple, of the RGB elements that make up that color, 25500 being red. From here, I can iterate over every single pixel in my image and get all the colors. So that's problem 1 solved. Problem 2, color setting. Yes, with a U because I'm Australian. But first, let's talk about floss. Dolphus Mjög Egg Compagnie is an Alsatian textile company that was founded in 1746, not to be confused with a hip-hop group of a similar name. When I talk about DMC, I mean this stuff. If you go to a Michaels or a Joanne, or in Australia a Spotlight or a Lincraft, you'll see a setup like this. This is known as DMC floss. DMC have several hundred colours of this floss available, all referenced by a code. This is a multi-strand medium that you can use 1, 2, 3, however many strands you want. in your cross-stitching, and then you build up your pattern by making crosses. They, however, don't only sell floss. I work in tapestry wool, also by DMC. It's slightly thicker, and I prefer to work with it because, I already have vision issues. But it makes for a more chunky aesthetic, and it works really well with pixel art. But the problem is that floss and wool are not cross-compatible. They do not share product codes, and all of those closed-source Windows-only programs had floss as the only palette you could use, so I was having to manually translate between the two mediums. These colours are part of the cranberry set, and while the names aren't strictly official, the codes are important. There is a guide for cross-compatibility that you can find, but it's absolutely supposed to be a guide. This is useful when you need to convert between floss and wool, but you can see that there's a little bit of a problem here. There are missing colours. In this particular set, there are 6 colours for floss and only 4 for wool, and my local shop only had 3 that I could take a picture of. This is slightly annoying, but it'll get worse. We are also working with computers here, and computers don't understand arbitrary colour codes, they understand RGB. So we need a way to be able to convert between RGB, between the DMC colour and RGB. Now, officially, no mapping exists. This is proprietary information. Colours can drift over time. In fact, if you're working on a large project, it's recommended that you buy all your threads at once because there can be slight variations between the different dye lots. And this is a company that was created in the 1700s, and it could be really easy to recreate or steal these kind of colours and thus undermine the entire ecosystem that this company is trying to make money from. However, there are ways around this. You can find unofficial mapping spreadsheets around the place. I've used this before to various effect, but you could create your own. You could go through every available colour thread, buy them all, take a picture in a white box room with the exact same lighting in the exact same environment, and from there determine what the best colour is in RGB to represent it. If you have a consistent photo shoot, this is fine, but there is differences between dye lots, variations in the warmth of the lighting that you use, and a whole bunch of other issues if you were to go about and actually take all these pictures. Thankfully, DMC has done this for you. On their website, they have all the colours available for all their threads. The names aren't referenced anymore, but those unique identifying codes are. The other thing, though, this is the list of all the pinks available in tapestry wool now. There are no longer any cranberry colours. In fact, according to the website, as of this year, they only sell 100 different colours of tapestry wool and yet nearly 500 colours of floss. Both these numbers are problematic. Back to this page, we can see that they've captured both the swatches and the full skein or spool or widget of thread. And we can use these images to work out what the average colour of these yarns are. How? Using Pillow. We can use imagestat.stat and get the median, the average colour for each of these pictures. How do we do that? In our terminal that we've previously pip installed Pillow, we can import both image and imagestat, load our colour swatch that we've downloaded from the website from our local file system, and run imagestat.stat, and then get the median, which comes out as a list of 3 colours, R, G, and B. And even though this projector has a lot of issues because projectors also have issues, this is a pretty good match on average of what that colour should be in real life. And because visualizations are fun, I've gone ahead and done a 3D plot scatter map of all the colours that are available for the floss palette. The 3 axes here are R, G, and B. And comparing this image to the image that's coming up on the next slide for wool, you can see that there's a little bit of an issue with the complexity of the palettes here. I mean, they've both got red and black and blue and white and green, but there's a whole lot of nuance that's being lost here. So we only have 100 colours of wool to work with. So we need to ensure that when we get our images out, that we're only using those 100 distinct colours, because they are the only colours that are physically available to us. And if you want to go dye your own colours, then that's good for you. But for me, I prefer to keep things a little bit simpler. Thankfully, we can reduce the exact colours that are in our image using Pillow, again, using image.putPaletteData. What we can do is we can provide the exact palette that Pillow uses to identify each of the exact colours in an image. Again, in our terminal, we want to import image, and then we need to provide a 768 length list of all the colours we want as a flattened list of 256 RGB value triples. So in this particular case, our palette would start with 000 black, 255 white, and continue on. We then need to create a new image to serve as our platform to store our palette data. The size of the image doesn't count, but the type does. The mode in this is P. P mode in Pillow is the palette mode, where instead of having specific RGB values, the palette data is a list of indexes that point to your own custom palette. From here, we use our list and we set that as the data. When we then load our image from source and tell it to convert to use our custom palette, all of the colours in that image are converted to only use the set we specify. There is a complex algorithm to work out how best to combine these colours into the one set and work out the smallest distance, and the math is interesting, but the fact that we can do this in Pillow out of the box is really great. Then we need to convert our image back into RGB and save it as an actual Python image, as a PIL image. You may see that I'm using some dunder methods in here from private use case. This is because the public API in Pillow doesn't actually allow me to do this, so I need to dive down into the C-level constructs in order to make this happen. But this particular algorithm does mean that I can specify any color palette I want and convert my image to only use colors from that palette. Now, that 256 number is a little bit special. You have a range of 256 integers that you can use to specify your RG and B. Pillow also defines the length of the palette as being at maximum and at exactly 256 colors. We have 100 colors in our wool palette, so that's fine, right? We only define 100 colors in our palette. Well, no. See, this is the part of the talk where I was going to mention the fact that I was getting this really weird bug in Pillow. What would happen is I'd define my 100 colors in the palette, load up my application, run it, and I would end up getting all these colors that were coming back that were grayscale. All these really light colors that were not available as DMC threads that I couldn't stitch were coming up, and they were always the same integers in the RG and B. Turns out that by default, a palette mode image in Pillow has a grayscale palette, and because I wasn't overloading this entire palette, some of these initialized values were coming through in my final product. So the solution here is to define your palette as exactly a length of 256 triples. And what I did was take my last triple and just copy it all the way until the entire array was reinitialized. And that works. But on the other end of the scale, we have a problem where there are too many colors in our floss palette. We have nearly 500 colors to work with, but only 256 spaces in which to store that in our palette. So we need to somehow truncate it. So how do we choose which colors we remove? Now, for any cross-stitchers or fiber arts people in the room, this is the part where it may be a little bit controversial, but I'm working with computers here and I have to make a compromise. All floss colors are different. They are so unique and so close in some of the browns and the creams that you can make entire tapestries where you cannot tell where the color is changing, and it makes for some beautiful artwork. Unfortunately, I'm constricted by computers, and I acknowledge this, and I am sorry. To reduce the amount of colors in our palette, we need to prune the colors that are closest together. And to do that, there is an algorithm. There is math. This is an algorithm put out by the International Commission for Illumination, which is to do with their experiences based on automotive paint on smooth surfaces. This algorithm is designed to kind of replicate human perception. You put in 2 colours and it'll show the distance between those colours. The bigger the number, the further they are apart. The smaller the number, the closer they are. And thankfully, because we live in a Python ecosystem, I don't try to have to implement this by hand. I can just import it from scikit image. They have made available the algorithm where if I provide 2 colours, it'll give me the distance. And again, in my terminal, I can import both NumPy and scikit image, load up my Python interpreter, import this particular formula, give it the 2 colours, and it'll give me the distance. For my entire floss palette, I can then go through and compare every single colour with each other, store that result, sort it by smallest distance, and come up with a list that shows just how close the colours are. This projector notwithstanding, these colours in real life are so ridiculously close together that if I had to choose, I can take my list and just go full Thanos on it. Again, not the best solution in the world, but I have my reasons. If we were to use the same visualization as before, this is our original floss palette. And then if I reduce it to only 256, we still get the complexity of colours. But we can work with that 256 more easily because reasons. Next problem, cross-stitch charts. Third problem, this one should be easy, right? We can just use Pillow. Well, that's been the solution for every problem so far, and I did try using Pillow. I've used Image Draw to try to replicate this system where I was building up a chart and I was making tables and concatenating squares together, but the results weren't what I wanted. I had weird default system fonts. I couldn't get Unicode characters to work. I was sitting there thinking there's got to be a better way, a way of being able to typeset any character with whatever styles and tables. Oh no, yeah, that's just HTML. Using HTML and whatever CSS styling I want, I can build up a page of divs and spans, the odd table here and there for my legend, and I can make my chart. So finally, I have these 3 problems solved. For image manipulation, we're using image.getPixel. For color setting, we're using ImageStat, putPalette, and then the scikit image formula that we described earlier. And then for the cross-stitch charts, we're using HTML. And the result of solving all these problems is a Python pip installable package called I. Now, why is it called I? Well, it's a cross-stitching app. There is a Disney movie called Lilo and Stitch. There is a character in Lilo and Stitch called Stitch. There is a scene in which Stitch is able to convey to another main character a complex persuasive argument by saying I. Plus, it's a super short name that was available on PyPI, so why not? The work in progress for all this stuff that I've done is also under a repo called Experiment 626 for similar reasons. And now I can generate a chart that looks exceedingly familiar to those closed-source Windows-only applications that I used 5 years ago. It also has some really nice features that I like, including the exact amount of stitches that I need, that I can then use my own estimations to work out how many physical skeins of wool I need. And I always have blanc, white, as the tiniest little dot that I can to make it look as normal as I can if I was to see this as a rendered image. So here's something I prepared earlier. This particular logo you may recognize, it's on every sign, including that one. And the Twitter logo is a similar format. Now, this image itself doesn't work well for this particular medium. Mostly, it's too big. Also, there's a gradient going on in the skyline. And for my particular medium, I prefer pixel art, where gradients are annoying. So I've recreated the PyCon logo in pixel art. Now, I'm no Paul Robinson, but that kind of looks like the logo, I guess. So in my terminal, I can pip install I, and I can run it on my tiny PyCon.image. And I get a HTML out, which is a cross-stitch pattern that I can use to then sit on a nice sunny Saturday afternoon in Australia on my couch with some YouTube channel happening on the TV, and then slowly but surely build up my image on my little tiny chart and tweet about this on Instagram, and then have my final image be this. you know what? That's too small. In what is now tradition, this will be auctioned off tomorrow night at the Pie Ladies charity auction. If you already have a ticket, I hope to see you there with your wallets out. It makes me really happy that as a community, we can really embrace the stuff that's not tech. We have a arts festival on tonight. We have other skills lightning talks at conferences. We have people who have brought their knitting. We have people that are crocheting in the front row, which is amazing. And I think there's like acro yoga somewhere later, and I'm all about that. So, this is now up on the warehouse, but if CLIs aren't your style, I have also wrapped this up in a Docker container, which I've hosted for you on Google Cloud Run. If you go to as a service, aah.glazen.com, you can use this, give it a URL to a particular image, and that will generate a chart for you. One thing it also does is it shows the rendered estimations of what's going on. So this kind of looks like a parrot. The hacky way that I got this to happen is to have each of those little squares as a semi-transparent image that allows the CSS color to shine through. And if I just copy that across and have all the colors come in, it looks like a rough estimation of what the result will be. If hosted stateless HTTP containers as a service is something that interests you, come talk to me at the Google booth afterwards. We have a service for that. Practical applications. So you can actually use this for techie reasons if you wanted to. Say, if you wanted to create a scannable QR code for your home Wi-Fi, you could pip install QR code, give it a string, save that as an image, and then import that image into and render it. Now, you do need to set the scale on this because the QR code is big. So if you want 1 pixel per square, you need to set the scale to 10 times reduction. And we're also setting the flag R here to render it. And we get a scannable QR code. And if you stitch this and put it on your wall in a frame, it works. And you can scan this rendering now, and it should work. Wow. Did it work? What does it say?
It's in French.
Yes! It says in French, this is not a password. I'm not going to put my home Wi-Fi password on a screen. Are you silly? So I clipped together these particular bits of Python about 18 months ago now and tweeted about it, saying that I had this thing that would make cross-stitch charts of your QR code, and that was a little tiny bit popular, and it got a little bit of attention. And because peer pressure is a thing, I made it into a CLI. And then, because peer pressure is also a thing, I've also hosted that up on Google Cloud Run as qr.glazen.com. You give it a string, it will give you a cross-stitch chart. So, I've extended the functionality of this project over the years based on what I wanted 5 years ago into a system that is now hosted that anyone can use. It supports various palettes, including floss and wool and alpaca, because I gave this as a lightning talk at LCA 2018, and one of the questions was, do you support other palettes? What about alpaca? I said, yes, but you would need an alpaca farm and be able to get all the different colors. They had an alpaca farm. It also supports Lego. It also supports perla beads, because those are palettes that are also available that I've been able to import into the system. I've also got some Twitter bots that are using this similar system. Come talk to me at the Pie Ladies booth afterwards if really silly Twitter bots that do cross-stitch charts of tiny care bot is something that would interest you. And that's all I had for those of you with a ticket to the auction tomorrow night. I hope to see you there, and thank you for your time. And once I get off stage, I will be taking my lovely tapestry to the Pie Ladies booth. Please follow me there. Thank you.